Every difficult task is just the sum of a lot of simple tasks. So there's nothing about this that's actually that difficult. If we understand what the question is asking us, work out the volume of water in centimeters cubed, it gives us everything we need. It's the volume of a cone we're given. It turns out that this volume here, okay, that's quite an unusual shape. We don't really know how to do the volume of that, but we have two cones. We have this larger cone here, and then we have this smaller cone up here. Now, if we take away the smaller cone from the larger cone, then we're going to get the volume of the water. And we leave our answer in terms of pi, so that means we don't evaluate what pi is, we just leave that within the answer. So first we can find out the volume of the larger cone, and we can just put it straight into this formula. We have a third of pi times by the radius squared, where the radius is 5, times by the height, which is 15. So that's nice and easy. We get the volume of that. Then we need to minus the volume of a smaller cone. And we can start to do the formula for that. So we minus a third of pi times by the radius. Okay, we don't know the radius. Now the height, that's easy enough to find because this distance here is 15, this distance here is 9. This must be a distance of 6, so our height is 6. There's two ways of thinking about this. We can think about if we looked at the cone from the side, we would see a triangle, and a smaller triangle, where these triangles are similar. This triangle here is basically just a scaled down version of the larger one. So this distance here, I have a radius of 5, and I want to work out what I've scaled this down to up here. To do that, we can think about what we scaled the height by. So we had a height of 15, and now we've times that by something. So 15 times by the scale factor has given us 6. If we rearrange this, we get that x is equal to 6 over 15, and that's our scale factor. So if we were to times 5 by 6 over 15, then 6 times 5, that's 30 divided by 15, we get 2. Our radius is 2. The other way of thinking about it is that the radius right at the top of the cone will be 0, and as we go down, the radius is continually increasing until we get to a radius of 5. So we are 6/15ths of the way down from the top. So 6/15ths of 5, whereas at the top. Again, we still get this here, where we get 2. So now we can just put that into the equation. We get that radius is 2, and then we get the height of 6. Okay, we've got all the algebra we need now. We don't need that diagram anymore. We can now just delve into what this is and simplify this down. So a third of pi times 5 squared, that's 25. Now, rather than doing 25 times 15, I'm going to do 1/3 times 15, which is 5. So I get 25 times 5. 25 times 4 is 100, so add another 25, we get 125. 125 times pi. Now remember, when you're doing multiplication, you can do them in any order at all. So I can do, if I had 2 times 3 times 4 times 5, I can do 2 times 5 and then times that by 3 times 4 if I wanted to. Or I can times it in this order, 2 times 3, then times by 4, times by 5. It doesn't matter, it's still going to give you the same answer. And we apply that principle up here, where we just times it in the order you want. And I'm going to apply the same trick again, so a third of 6 is 2, times that by 2 squared, which is 4. 2 times 4 is 8. So I'm going to minus 8 lots of pi. 125 minus 8, that's going to give us 117. So our answer is 117 pi. Now just to see if that is reasonable, this is about 100, that's about 3. So about 300. Does that seem reasonable? I'd say so. Because if we were to work out our volume here of 125 pi, 125 times 3, that's about 375, so this does seem about accurate. We're just missing out this little bit of volume up here.